Okay, YouTube, in this video we're going to look at an instance in which matrix multiplication would actually be a really convenient way to find some values that we're interested in. So let's go ahead and take a look at this situation here. It says 2 softball teams submit equipment lists, and it says each bat costs $80, each ball is $6, and each glove is $60. So we say, what is the total cost of the equipment for each team? So you can see here, and I formerly had women's and men's. I meant to have Team A and Team B up here, so I scratched it out and put those, but we say, here's the equipment list for Team A, here's the equipment list for Team B. What we want to find is a total amount for like our bats, a total amount for our balls, and a total amount for our gloves, but all of this equipment together. Basically, I want to find those amounts. And so the interesting thing is this, for Team A, what we could do is, since bats are, we can write this down here. I suppose we know that bats are $80, balls are $6, and gloves are $60. The interesting thing is to find the total. If I wanted to find the total, what we could do is we could just say take 12 times 80, and then take 45 times 6, and take 15 times 60 here, because we have 15 of these $60 things, 45 of these $6 things, and 12 of these $80 things. And what we'll do is we add these up. And I would do the same thing over here. I would take this times 80, this times 6, and this is times 60 to get the total bill over here. And so what we're looking for are these two totals. So essentially what I want to point out here is this. What we can do in terms of matrix multiplication is that we can come up with we'll call it a cost matrix. And this cost matrix here I'm going to make is a 1 by 3. I'm going to call this 80, 6, and 60, and we'll talk about why this is appropriate here. And we're going to take it times now what I'll call, I guess I would say, our equipment needs matrix. So we say equipment matrix. I'm just going to write equipment matrix because my handwriting is bad and you don't want to see the rest of it. So we say 12, 15, 45, 38, 15, and 17. And so the interesting thing about it is that we have this 1 by 3 matrix, of course, here, and we have a 3 by 2 matrix. And so in terms of multiplication, could we do this? Could I multiply these two things? I would say certainly, because the inner dimensions match. What I know is that I'm going to get this new matrix that would have the outer dimensions that these two matrices have. So I'm going to get a 1 by 2. This means a 1 row, 2 column matrix. I'm going to make these rather large here just to leave myself some room. But basically, I have this 1 row, 2 column matrix here that I'm going to get as a result. And my result, the interesting thing here is what we wanted to find were the totals for each team. So we said finding these and adding them together, this truly would be our matrix multiplication in this case. So because this is the first row, first column entry right here, we're going to take the first row of this matrix, which by the way is our only choice on this first row matrix in our product, times the column matrix over here. We're going to take it times its first column. So we'd say 80 times 12, which is what you see here, 80 times 12, plus now 6 times 45, plus now 60 times 15. And so really was a stretch to kind of fit that in there, and these are larger values, but we'll find it on a calculator here. But basically you could see how we took the first row times the first column entries here, and now we're going to go back to get our first row, second column entries. We're going to take this first row times the second column over here. So we have 80 times 15 this time. So we have 80 15s. Can you fit it on the screen? 80 15s. Plus now we'll move over 1 and move down 1 here. 6 38. So 6 times 38 plus, it ain't going to fit you guys, 60 times 17. We say 60 times 17. So all of this can certainly be found. What I did was I took the liberty of going ahead and typing in this matrix multiplication problem here into my matrix menu. So my 1 by 3 here is this. I'll just pull it out here and show you 80, 60, and 6. And then my other matrix here, which was that 3 by 2, is just this one right here, is our equipment need matrix. And then what we should get is this new matrix right here that represents the total cost. We're going to say total cost matrix. So just to check out what these values would be, let's go ahead and take now matrix A. We'll say matrix A in this order times matrix B. Remember, it's not commutative. We'll hit enter, and so we get this 2130 and 2448. So we have 2130 and 2448. And if we wanted to interpret this, what we could say is this is the cost, total cost, and we would say that this is team. Let me try this again here. Team A total cost, and this would be team B total cost. Cheers.